Now, if you're not already somewhere comfortable, find a cozy spot, grab your favorite drink, and settle in. Because we're about to take an incredible journey across the universe. By the time this video ends, one of two things will happen. You'll either completely lose your sense of who you are and where you fit in the cosmos, or, strangely enough, you'll come away with a deeper understanding of your place in it. So, are you ready for an existential adventure? If you are, make sure to subscribe. According to current estimates, the observable universe stretches about 46 billion light-years in every direction, even though it began roughly 13.8 billion years ago. At first, that sounds impossible. How can something that's 13.8 billion years old be 46 billion light-years across? The answer lies in one of the most fascinating features of our universe. Space itself has been expanding ever since the Big Bang, and that expansion has been accelerating for billions of years. The speed of light limits how fast things can move through space, but it doesn't limit how quickly space itself can expand. That's a fascinating topic on its own, and we'll save it for another time. Still, when we hear a number like 46 billion light-years, we usually just think, wow, that's huge. But the truth is, numbers that large are almost impossible for the human brain to truly picture. They're too abstract. To understand them, we need something we can relate to. That's exactly what we're going to do today. We're going to put the size of the universe into perspective. And by the end of this journey, we'll also answer an important question. Why does any of this actually matter? Let's begin at the only place we can truly call home, our own pale blue dot, Earth. Believe it or not, Earth isn't a small planet. To make that easier to imagine, suppose you got into a car and drove non-stop around Earth's equator at 60 miles per hour. No breaks, no sleeping, no stopping for food. It would still take you more than 10 days to make it all the way around. Even if you boarded a commercial jet, you'd still be traveling for over 2 days. So no, our planet isn't tiny. Humanity has spent hundreds of thousands of years living, building civilizations, and disappearing on this rocky world. And even now, we still haven't seen all of it. In fact, many people spend their entire lives within a relatively small area, never visiting another country, or sometimes never even leaving their own state. But our imagination has no such limits. So let's leave Earth behind and head to our closest celestial neighbor, the Moon. When you see photographs, movies, or animations, the Moon often looks like it's practically within arm's reach. On a full moon night, it almost feels as though you could reach up and touch it. In reality, it's about 239,000 miles away. Imagine building a highway straight to the Moon. If you drove that same car at 60 miles per hour without ever stopping, the trip would take more than 6 months. 6 months later, you finally arrived. So far, the Moon is the most distant world humans have ever set foot on. Only 12 people have walked across its surface. That's one of humanity's greatest achievements. But our journey is just getting started. As we zoom farther out, the rest of the planets come into view. In diagrams and animations, they often appear neatly lined up, looking surprisingly close together. That's only because the true distances are impossible to show accurately on a screen. The reality is very different. Our solar system, tiny as it is compared to the universe, is enormous on a human scale. Let's climb back into our imaginary car and head toward the sun. Traveling non-stop at 60 miles per hour, the trip would take roughly 177 years. Even aboard a commercial airliner, it would still take about 19 years to get there. And that's just the sun, the star we casually refer to as being right next door. What if instead we aimed for Neptune? That would be another story entirely. Driving there non-stop would take well over 5,000 years. Flying in a passenger jet would still require around 600 years. So yes, the solar system is unimaginably vast. That's why even the idea of colonizing our own solar system remains an extraordinary challenge. Fortunately, even if humans can't travel those distances yet, the machines we've built can go much farther. Spacecraft travel dramatically faster than cars or airplanes, often exceeding 20,000 to 30,000 miles per hour, sometimes even more. Right now, the most distant human-made object ever launched is Voyager 1. It left Earth in 1977 and has been racing into deep space for nearly half a century. It crossed the boundary of interstellar space in August of 2012 and now sits more than 14 billion miles from Earth. Even traveling at the speed of light, it would still take about 21 hours just to reach Voyager 1's current position. And remarkably, NASA still tracks its location and trajectory in real time. Now it's finally time to leave our cosmic neighborhood behind. But there's one problem. Where exactly does the solar system end? There isn't a single universally accepted answer. Some define the edge as Neptune's orbit. Others place it much farther out, beyond the region dominated by the Sun's gravity. Many astronomers point to the Oort Cloud, a vast shell thought to contain billions, perhaps trillions, of icy objects and comets, as the true outer boundary. The difference is enormous. If we treat Neptune as the edge of the solar system, light would cross that distance in roughly 4 hours. But if we extend the boundary all the way to the distant Oort Cloud, then even light itself would need about 1.5 years to make the journey from the Sun. Depending on where you choose to draw the line, the edge of our own solar system could be 4 light hours away, or 1.5 years away. And that's an astonishing difference. To really appreciate what these distances mean, let's remind ourselves just how fast the speed of light actually is. Light can travel from Earth to the Moon in about 1.3 seconds. It takes just over 8 minutes to reach the Sun. That almost makes it feel like, if we could somehow travel at the speed of light, we'd have solved the problem of distance forever. Not even close. As you've already seen, even moving at light speed, simply reaching the outskirts of our own cosmic neighborhood could still take more than 1 year, depending on where you define the edge of the solar system. And believe it or not, we're still just getting started. So far, we've barely taken our first step into the universe. Now let's compare our enormous solar system with something much larger. Our home galaxy, the Milky Way. The nearest star to us, Proxima Centauri, is about 4.24 light-years away. It sounds close by cosmic standards, but let's put it into perspective. Suppose we tried driving there at 60 miles per hour without ever stopping. The trip would take roughly 47 million years. Too slow. Let's catch a commercial flight instead. That cuts the travel time down to about 5 million years. Still not good enough? Then let's hop aboard Voyager 1. Or at least imagine traveling as fast as it does. Even at that incredible speed, reaching our nearest stellar neighbor would still take around 73,000 years. That's the closest star. To put that into human terms, assuming an average lifespan, about 2,500 generations of people would be born and die before the journey was complete. And Proxima Centauri is only the beginning. The brightest star in Earth's night sky, Sirius, sits about 8.6 light-years away. As we zoom farther out, we begin to see our local stellar neighborhood. Within about 50 light-years of the Sun, there are more than 50 known star systems. Some are too dim to see with the naked eye, while others can be spotted from much farther away simply because they're so enormous. Take Deneb, for example. It's roughly 2,600 light-years away, yet it's still easy to see in our night sky because it's thousands of times more luminous than the Sun. Even our immediate stellar neighborhood is staggering. Crossing just this relatively local region would still take Voyager 1 more than 1 million years. Beyond that, we reach something called the radio bubble. This invisible sphere marks the farthest distance our radio broadcasts and television signals have traveled since humanity first began transmitting them a little over a century ago. Every broadcast, every news report, every sporting event, every television show, every message we've accidentally leaked into space has expanded outward at the speed of light. Today, that entire bubble is only about 100 light-years across. In other words, all the evidence that humanity even exists has barely reached our nearest cosmic neighbors. If there's an advanced civilization on the opposite side of the Milky Way, they haven't heard from us yet. As far as they know, Earth is still completely silent. Within this radio bubble lie only a few thousand stars, a tiny fraction of our galaxy. Now, let's zoom out even farther. 1,000 light-years sounds unimaginably distant. But on the scale of the Milky Way, it's less than 1% of the journey across. That's when the true size of our galaxy starts to become almost impossible to comprehend. Astronomers estimate that the Milky Way contains somewhere between 100 billion and 400 billion stars. And before we move on, it's worth pausing for a moment to think about what a billion actually means. Counting to 1,000 would take only minutes. Counting to 1 million, one number every second without stopping, would take nearly 12 days. But counting all the way to 1 billion, that would take over 31 years. That's how enormous a billion really is. Now imagine not 1 billion, but hundreds of billions of stars. And if even a fraction of those stars have planetary systems like our own, we're talking about hundreds of billions, perhaps even trillions, of worlds scattered throughout a single galaxy. Just one galaxy. The Milky Way itself stretches roughly 120,000 light-years across and is about 1,000 light-years thick. Those numbers are difficult to picture, so let's shrink everything down. Imagine our entire solar system were the size of a small coin. On that same scale, the Milky Way would be roughly as wide as the continental United States. Finding one particular solar system inside it would make searching for a needle in a haystack seem easy. And remember, somewhere on that tiny coin sits Earth. So small that on this scale, it would be less than a speck of dust. And somehow, every human who has ever lived has existed on that almost invisible speck. But that's only our galaxy. Let's keep going. Leaving the Milky Way behind, our nearest major galactic neighbor comes into view. Andromeda, located about 2.5 million light-years away. Zooming out farther still, until our view spans roughly 100 million light-years, we begin to see our local group embedded within an even larger structure known as the Virgo supercluster. Instead of stars, we're now looking at thousands of entire galaxies, each one containing hundreds of billions of stars, each with countless planets of its own. And we're nowhere near the end. As we continue pulling back, more and more superclusters appear, connected across the cosmos like enormous strands in a vast cosmic web. Some regions seem strangely dark, not because there's nothing there, but because our own Milky Way blocks our view in those directions. And as we zoom out even farther, we begin to see structures that formed when the universe itself was still young. As we continue pulling farther away, we begin to encounter some of the brightest objects in the universe, quasars. These extraordinary galaxies are powered by supermassive black holes, consuming enormous amounts of matter, producing so much energy that they can outshine entire galaxies. And eventually, we reach the oldest light we can possibly see, the cosmic microwave background eye. This faint glow is the leftover radiation from the Big Bang itself, a snapshot of the universe when it was only about 380,000 years old. Looking in every direction, this ancient light forms the ultimate boundary of what we can observe today. Beyond it, light simply hasn't had enough time to reach us since the universe began. This is what we call the observable universe. Within this enormous sphere are an estimated 2 trillion galaxies. 2 trillion. At this point, numbers have almost lost their meaning. So, is this everything? Not necessarily. Based on what we currently know, the observable universe spans about 46 billion light-years in every direction. But that's only the portion we can actually see. What's beyond it? No one knows. In fact, when scientists account for the ongoing expansion of space, many models suggest that the entire universe could be vastly larger, perhaps hundreds of times greater than the observable portion. We're no longer talking about billions of light-years. We're talking about distances measured in trillions of light-years, or perhaps even beyond anything we can meaningfully imagine. And that brings us to the real question. So what? What does knowing any of this actually do for us? The answer is deeply personal. But throughout history, for philosophers, scientists, explorers, and some of humanity's greatest thinkers, this question has never just been about the universe. It's been about ourselves. Because our attempt to understand the universe has always been inseparable from our attempt to understand who we are. The more we discover about the cosmos, the more clearly we begin to see our own place within it. In a sense, we're not studying something separate from ourselves. We are the universe trying to understand itself. Every one of us is connected. Biologically, we're connected to every living thing on Earth through the shared history of life. Chemically, we're connected to our planet. And at the deepest level, every atom in our bodies was forged inside ancient stars that lived and died billions of years before the sun ever existed. We are quite literally made of stardust. That realization changes the way many people see the world. It reminds us to treat one another, and every living thing, with greater compassion and respect. It reminds us that while we may seem unimaginably small against the scale of the cosmos, that doesn't make us insignificant. In many ways, it makes us extraordinary. Against impossible odds, the universe produced stars. Stars created the elements. Those elements became planets. One of those planets gave rise to life. And eventually that life evolved into beings capable of asking questions about the universe itself. When you truly grasp that every atom in your body once belonged to long-dead stars, everyday conflicts begin to feel much smaller. Petty arguments, endless divisions, and many of the worries that consume our lives lose some of their weight. Most of all, it reminds us that our time here is incredibly limited, and that makes every moment we have infinitely more valuable. Until next time, thank you for being here. Take care of yourselves, and keep looking up.